Hi, Assalamualaikum warahmatullahi wabarakatuh. To my lecturer, Dr. Nuzaima binti Mustafa. So today we would like to do presentation about the non-destructive testing on product analysis defect. So we would like to introduce our group member first. And first the Elsee Layu. Second Abdul Muiz bin Mohammad Sukri, and me Muhammad Afiq Asna bin Mohammad Hasni. So here in the introduction of the assignment. In 1930 somethings, magnetic particle test is developed in United States to inspect steel component assembly lines. The approach of the premise of magnetizing the specimen from magnet line of force or flux in the materials. When the lines of force intersect with the defects such as fracture, secondary magnetic poles form one fracture faces. Magnetic particles, either a powder or in a liquid solutions, can be used to disclose where these secondary magnetic fields emerge on the material surface. So the particles are drawn to the flux, leakage and form group around it, so making the problem evident. So the particle might be black or fluorescent dyed to make them more visible. Furthermore, magnetic particle examination and is a standard low cost non-destructive testing approach for ferromagnetic materials. So this MPI become one of the most commonly used to detect the flaws or defects in the ferromagnetic pipeline or pipe wells, both. So in the surface, also in the near subsurface levels. So now I will talk about the predict the potential defect might occur on the surface. So as we can see on the figure above, there is the water pipe. So any pipe or tube to deliver the purified water to a customer is referred as the water pipe. Therefore, like example, we can see a large diameter of pipe through the city and also street, and others is inside or outside the building. So that is the one example. So therefore, type of defect that might occur on such water pipes are cracks in the surface or inside the pipeline. It is increasingly high water pressure can cause damage to this pipe. As also we can see the picture, there are high possibility cracks happen on the welded joints between two pipes. So all these predicted defect in these water pipes will be inspected on the potentially affected on it.
Hi, my name is Muiz. I will explain about selecting and planning a non-destructive testing method. So in this testing, we performed on the steel water pipe, and then magnetic particle testing was selected. So there are 4 types of NDT planning inspection consideration. For the first all, the type of damage mechanism to be inspected for, the minimum detectable flow size, shape and orientation of the defect, where the defect is located surface or internal, the sensitivity and limitation of the NDT method. So next, we planning the NDT using flowchart. So for the first all, we need to select the object, which is we select the steel or water pipe, and then we make a visual review. Then so decide the type of NDT to perform, which is MPI, particle testing, and then choose the component area to apply the MPI. Apply MPI to the chosen area of the component, and then so if we detect the defect, just proceed, and then if don't have a detect, we choose the different area. So next, interrupt type of defect, and then record the result. That's all, finish. So I will pass to the next presenter.
Hello and good day to Dr. Nuzaima. My name is Elsee, and as explained by my friend Asna and Muiz, our project's gonna discuss on the magnetic particle inspection as our non-destructive testing as our method, and water pipeline as our subject to be inspected. Alright, as for my part, I'm gonna discuss on the type of defect that usually or commonly occur in pipeline and what type of defect that MPI could detect it. Alright, the common defect that usually occur in pipeline is that during fabrication process, where the welding process is not done accurately, and some errors might occur during the process when the person in charge during the welding process is not doing it in the right parameter, and there may be some human error that happen during that process, which lead to weld defects. As shown in this picture, there are few types of welding defect that could be detected using this MPI. However, the defect that could be detected using magnetic particle inspection is that pore, cracking, and leg side wall fusions in the weld. But MPI is an effective method that we can say because it can detect defect in the surface breaking and the slight surface defect. But for MPI, it's only work on ferromagnetic materials such as iron, nickel, cobalt, and some of their alloys. Alright, so we are reaching at the end of this presentation, so I will summarize what we have learned in the whole assessment given. Alright, the first thing is that most importantly, students are able to understand and know what is the capabilities of this MPI, what type of defect that it could detect in pipeline or any other materials. And other than that, students also know how to apply and understand the concept of MPI. And lastly, maybe in future we could really apply this technique in real life. So thank you and goodbye.